Hey everyone, if you ever looked at a chart and wondered how did they make that from raw data, if you ever seen a recommendation algorithm and thought I want to build that, then you are in exactly the right place. My name is Devansh Singh and this is the Data Science Fundamental Workshop brought to you completely free by HackSkill. Over the next 15 days from March 23rd to April 7th, we are going to go from Python basics all the way to building your first machine learning model, and we are doing all of it right here on YouTube. No paid platforms, no logged content, and no excuses. This is module 0, our kickoff video. We'll get your environment set up, do a Python refresher, and by the end of this video, you will have run your very first data science code in Google Colab. Let's get into it. Slides are moving. Follow along. So, before we dive in, let me tell you a little about who is bringing you this. HackSkill. It is a community driven tech education platform with one mission to make high quality, industry relevant tech education accessible to every learner in India, regardless of their background or budget. We had thousands of learners go through our workshop, and what makes us different is that we focus on what actually gets you hired, not just theory, but real skills with real projects. This workshop specifically is 15 days, completely self paced, 100% free, and comes with an industry recognized certificate on completion. The registration link is in the description. Register because the certificate is tied to your name and completion, and it's something you can put directly on your LinkedIn and resume. Now, let me introduce myself. My name is Devansh Singh. I'm an ML engineer and currently interning at Infosys, working on real world machine learning systems. I'm also a certified alumnus of the Amazon ML Summer School, one of the most competitive machine learning programs in India. If you don't know what that is, it's an Amazon's own ML training program where they select engineers from across the country. Getting in one was one of the most challenging and rewarding experience of my career so far. I'm teaching this workshop along with Aditya Srivastav because everything I cover here, NumPy, Pandas, data cleaning, statistics, ML, these are the exact tools I use professionally every day. My promise to you is this: no fluff, no theory for theory's sake. Everything we do together will be grounded in what's actually used in industry. Alright, let's talk about what data science actually is. So, data science sits at the intersection of three things: statistics, programming, and domain knowledge. Statistics gives us the mathematical language to understand data. Programming, specifically Python, gives us the tools to work with it at scale. And domain knowledge means understanding the problem you're solving. A data scientist at a hospital needs to understand medicine. A data scientist at a bank needs to understand finance. Now, look at the life cycle at the bottom of this slide. This is the pipeline every data scientist follows. First, you collect data that is going to be raw, messy, it's going to be a real world data. Then you clean it, remove errors, handle missing values, and then you explore it. Basically, find patterns, visualize distribution, and then you model it, build a machine learning model, and finally, you extract insights. Tells this, tell the story that data is telling. But here's the reality, guys: 80% of a data scientist's time is in the first two steps. That's why this workshop doesn't skip data cleaning. It's unglamorous, but it's what separates good analysts from great ones. Every module in our workshop maps to one of these life cycle stages. By the end, you will have walked through the full pipeline on real data set. Now, here's the full roadmap of our 15 days together. Module 0, that's today, is your foundation. Collab setup, Python refresher, your first imports. Module 1 is NumPy, the numerical computing backbone. Module 2 is Pandas, how we work with real data sets. Module 3 is going to be data cleaning, the unglamorous skill everyone needs. Module 4 is visualization, basically making data beautiful and meaningful. Then comes statistics, the math behind the insights. And in the sixth, your capstone, basically building a real world machine learning model that is going to be end to end. 7 modules, 11 YouTube videos, one free certificate. We have a lot to cover, so let's get straight into our tools. And here's our complete tech stack for this workshop. Python 3 is our language. If you have some Python experience, great. If not, we'll cover everything you need in today's video. Google Colab is our environment, cloud based, free, zero installation. All you need is a Google account. NumPy, Pandas, Matplotlib, Seaborn, these are our four core libraries. We'll spend full modules on each of them, like complete modules dedicated to each one of them. And scikit-learn gives us machine learning for module 6. The best part, Colab comes with all of these pre-installed. Now, let me show you. Google Colab is going to be your coding home for this entire workshop. Let me walk you through what it is and why we are using it. So basically, Cloud Colab is a cloud notebook. Think of it like Google Docs, but for Python code. It runs entirely in your browser. No installation, no setup, no compatibility issue. If you have a Google account, which you almost certainly do, you are ready to go. On the right side of the slide, you can see what a Collab notebook looks like. It has two types of cells. Text cells, these are white and they use Markdown. I'll use these to explain concepts between code blocks. And then we have code cells. They are gray, and this is where Python runs. You click the play button on the left or press Shift plus Enter. A few powerful features that are worth knowing in Google Colab. First, Google Drive integration. Your notebook saves automatically to your drive. You'll never lose your work. Second is free GPU access. Go to runtime, change runtime type, and select GPU. This becomes useful when we go get to machine learning in module 6, so I'll demonstrate it at that time. Now, third is sharing. You can share a notebook link just like a Google Doc. The notebook for today's video is in the description. Open it, make a copy to your own drive, and follow along. All right, I'm going to switch to Google Colab and let's actually write some code. What do you say? So here we are in Google Colab. As you can see, I've already connected to a runtime environment and my Python. And this is how a Google Colab UI looks. When you first log into your Google Colab, it's gonna show you a pop-up. And if you look towards your bottom left, there will be an option of new notebook. Just add it and change your name here, and it will be easier for you to navigate once it gets saved to your Google library, right? Now, all right, we are in Google Colab and welcome to your first Python code. Now, let's start with the most fundamental concept in any programming language, variables. A variable is just a labeled box that holds a value, right? Now, I'm going to use few examples that I have added already in my slides. You can see them here, and what I want you to do is follow along what I'm doing in this video. So I'm going to select my first text cell and create a variable named name. I'm going to store my name, and keep in mind the syntax which I'm going to show you. Like here I've added my name inside quotes, and that is single quotes. Now I'm gonna make another variable of age and add my age when I'm using a numerical value, so directly I can use it. I don't need to use any quotes. Now I can use another variable that is going to be score and add my score that is going to be 92.5, let's say. And another variable is pass, and I'm going to make it a boolean variable. So I'm gonna store a boolean value in this, right? Now I've made some variables, stored some values, and now I want to know what data type each um, variable is storing. So I'll print it. Like if I pass directly print a name, it's just gonna print my name, but I don't want that. I know you guys know that already. So what if I write type and then pass name parameter? So I'm gonna show you for each one of them directly print type score and print type is pass. So I've written it. If I press shift enter, the program runs and you can see It shows what type of data type my value is stored in the name variable. So Devansh was a string variable, then the age was an integer value, my score was a float value, and is passed had a boolean value in it. Now, these are the four data types, and in data science, you will see all four constantly. Strings for names and categories, integers for counts and IDs, floats for measurement and prices, booleans for condition and flags. Now, before we move on, I also want you to get familiarized with f strings. Basically, these are the cleanest way to print variables. Now, I'm just gonna add it here. F strings, clean, cleanest, I guess, cleanest way to print variables. Variables. Now, what do mean by f strings? So if I write print and if I pass f, my name is, instead of changing the value each time, if I just refer it to a variable, that is name variable, it will show me exactly what I need just by calling out to that variable. And if I run this program, you can see it fetched the value from the variable and it is being shown here. You can obviously add more codes to it, and we'll discuss about that later. Now, make sure you understand these concepts, like the variables are being put inside a curly brace. So make sure you remember this. And besides that, let's discuss a few more things about f strings. So f strings are basically lowercase f before the quote, right? Then curly braces around your variable, simple as that. And you will use this all the time, much cleaner than string concatenation, you can say. So great. Let's move back, and now, yeah. So now let's talk about the two data structures you will use most in data science: list and dictionaries. A list is an ordered collection of items. Think of it like column in a spreadsheet, right? Now I'll use the same example I have used here. And first of all, let's add it. So we are discussing lists right now, and this is our code, and you can see. Uh, Wait, we'll discuss every code one by one, I guess. So, okay, okay, I don't know why it is printing a rupee sign in my Mac, so we'll discuss about that later. Okay, so I have what I did here, right, was create a list named scores, and I have added these values in that, as you can see, like 82, 88, 92, 79, 95, and 84, right? And what I'm doing is printing, what I'm going to do is print values, like print the value of the first item in this list. So always remember that the list start with the index value 0. Okay, I'll point it out later on also, but for now, just remember that. Now, if I have to print the last value in the list, I can just do it like this, like use -1, and then it prints the last item. If I want to print a range of numbers, then I can use 1, then colon sign and 3. So it prints 92 and 75, 79. So how it did that was basically, what happened here was, if you start from here, so this is zeroth index, one, second, third, and fourth. So I gave it a range of 1 to 3. So this is our third item. So it doesn't include the third item, but includes from first to third. So first is included and not the third item, but before that. So if I had pushed 1 is to 4 and ran it, so it would have printed me 95 too. But for now, I haven't done that. Now, what if I want to check what is the length of my list? You can do it by passing length parameter. Also, if I want to add any item in this list, I can use append, and if you do that, oh, okay, sorry. I will have to print the value also, scores. Okay, so now if I run this, you can see 91 gets added to our list. And basically, what things you have to remember is index is going to start at 0, not 1. So the first item is scores in square bracket 0. This is true in Python, NumPy, Pandas, everywhere. Now, once we are done with this list, as you can see, now let's discuss something about dictionaries. Okay, I'll simply and quickly copy the code I have already added in my slides. Now, here you can see that what I have done is make a data set first of all. So let me just do it in a more cleaner way here. Yeah. So this will help you understand a bit um, early what I mean by it. What I am doing here. So think of a dictionary like a column, a row. My bad. Think of it like a row, right? And I've created a few key values here. Like I've created a few keys like name, age, score. Similarly, I've added Alice, and everything else was same we did first of all. Now if we print student name, Alice will get printed. If we student like grade, if I want to add a new key, I can just do that by passing the dictionary and then adding it inside a square bracket, and then also add its value in it. So grade A, as I had already added a score of 92.5, anything above 90 can be considered a A grade. So now if I want to print all the keys, like the key values, if I run this, you can see all the values here. And if I print student itself, okay, my bad, and I run this, so you can see everything gets printed like the name is Alice, age is 21, score is 92.5, grade is A. Now, one more thing you must be seeing is why are these values being shown in quotes? That's because I have added them in double quotes. If I use single quotes here and then run this code, it will produce the same result, right? Nothing gets changed. You can use a single quote or you can use a double quote. Hey, that is the base of it. Like you can use any of them. And now, what I need you to understand is a dictionary maps keys to values. Okay. Now, name, age, score, here are the keys in these dictionaries, and Alice 2192.5 are the values stored in these keys. And this is exactly how a row in Pandas data frame is represented internally. You will see this pattern again when we'll discuss Pandas in module 2. Now, moving along, let's move on to the next slide, and it's about loops and conditions. Now, loops in data science, you rarely write loops by hand because NumPy and Pandas do it for you under the hood. But you need to understand them because they form the logic behind everything, right? So, as you can see, we'll discuss this on the go in the slides itself. I have used the same data set of 88, 45, 92, 34, and 77, slightly different. Now I create a for statement for score in scores. Like this is the score value which I'm, you know, uh, defining right here, initializing it basically, and I'm explaining it that for score in scores, like this is our list, right? So if score is greater than 60, now I've already initialized what score is, right? So if the value of score is greater than 60, we will print it pass, else we'll print it fail. Now if I pass 88, the value gets a pass. But if we use 40, 45, we are shown a fail. Okay, so notice the indentation. Python uses four spaces to define code blocks. No curly braces like Java or JavaScript, right? The indentation is the structure here. Now let me actually run it for you. Okay, quickly we'll discuss this. If I run this, you can see 88 was marked as pass, 45 was marked as fail, 92 was marked as pass, 34 was marked as fail, and 77 was also marked as pass because these values exceeded 60. Now, also, one of the mm, crucial, you can say, uh, things you should, learn in Python or basic data sciences, list comprehension. Basically, a one-liner version of what we did in loops, right? Like, let's just say, okay, this is a far much larger code. But if I have to use a single line code for doing the exact same thing what I did here, okay, but I only want to see the passing values. So what I will do is create a new variable passing equals s for s in scores if s is greater than equal to 60 and print passing scores. Okay, passing. Now, if I run this, you can see it is a one-liner version of similar thing what we did earlier, but it will only show us the scores that I have already passed and not show what marks were failed. So basically, it's the same result, but it's in a single line, and this is called list comprehension. I know it's very Pythonic. You'll see it everywhere in data science code because it's very quick. And you can see I have added a pro tip here that you will mostly use NumPy vectorized operation instead of loops because that they are much faster, Now let's discuss about functions. Now functions let you package reusable logic. In data science, you will write functions to clean columns, categorize values, and transform entire data sets in one cell. Now you can use this example what I'm showing you right here. Now this is a basic function. I defined a function greet and passed name variable that I had used in the earlier version. And now if I return f string hello, the name variable, welcome to data science, it will print. Then if I print greet and in the argument I pass Devansh, it will show you my name. Let me just show you this same example here. Now, if I run this, you can see because I have already passed Devansh in the name argument here. So it shows hello Devansh, welcome to the data science after it was asked to when I called the function again. Right. Now, there's a great example here. You can use it directly when you are, messing up with my Google notebook here, Google Colab notebook, sorry. Now, I would like you to, get messy with this functions and all because that's the best way you can learn. But yeah, default arguments are powerful, but they make functions flexible. Yeah, and the last line here, applying a function to this, function, right? The argument that I passed. You'll see this exact pattern in pandas with the dot apply method. Okay, the dot apply function method. Okay. Before we move on, I'll use this example also, I guess, if there's anything I could show. Okay, so this is a basic function, so you can experiment with it itself. And let's move on. So if anything, okay. Also, let's discuss about lambda. So lambda is a mini function, right? It is used a lot with pandas, and in module 2 we'll go deep about it. But for now, that is it. If like let me show you an example of lambda, right? Lambda function, lambda. So if I create a value double, like a variable double, and I ask lambda x is to x into 2. Yeah. If I pass this and if I write print double and I pass value of 5, let's see. And if I enter it, it will already execute for that 5 into 2. Now you can define a lot of things here, like 5 plus 2 divided by 6, and you know, percent 2. I don't know its value myself, so if I even run this, so it throws an error, error directly. So you can't do everything with it, like if only a single parameter, like you see. So you have to remember that you can't just write anything into it. Keep in mind that syntax is also important, and we'll discuss it deep into the module too. Now, let's move on to the next slide, and the essential imports, right? So these are a few essential imports we need to understand. Import numpy as np, import pandas as pd, import matplotlib uh, dot pyplot as plt, import cbond as sns. If we run this, okay, what I need you to understand is we get we are getting it in the most important cell you will write in every single data science project and forever. These are the four imports that you are going to use forever in any data science project. Now, if I run this program, you will see there is no output at all because we are just importing these, and that's perfect. And this explains why imports are silent when they work. If you see a red arrow, just in case, it means the library isn't installed. Like if you're working in a VS Code or any ID, it may throw an error because you haven't installed it. Now in Collab, if it shows you a red error, just run exclamation mark pip install numpy pandas matplotlib cbond everything. Like I'll just add this here. So if you see an error, just run pip install numpy pandas matplotlib dot pyplot and cbond. Now let me tell you about each one, what each one of these does, right? NumPy, which we have imported as NP, is used for numerical computing, basically arrays, math, random numbers. This is the foundation everything else is built on. Now, pandas as PD is used for data manipulation, data frames, loading CSVs, using group by. Basically, this is your spreadsheet in Python. Now, matplotlib.pyplot as PLT is basically being used for plotting. The original, basically, it's the original charting library of Python. Now, Cbond as SNS is used for statistical visualization on top of matplotlib. And a single line, you could say, is beautiful charts in one line. These four lines are the opening of almost every data science notebook ever written, and they are your toolkit. And I need you to treat them like that. Now, we are on the live coding demo, but I guess I've already done it everything with you. We have discussed variables and types, lists and dictionaries, loops and functions, numpy as np, pandas as pd. And first data frame, we will do it tomorrow itself. Like whenever module 1 gets uploaded, you will be able to see it. But yeah, I guess we still have a few minutes left, so let's create your. I want you to give you a teaser of what's coming in module 2 right now. Let me show you how easy it is to create and look at a real table of data. Now we have already made a new code cell, and this is going to be your first data frame. No, pandas data frame. Now first we'll create our data set, demo data set. Let's start with name. I'll add a few names like Alice and Benton, Bob, Kara, Dave, and let's see, okay, Eve. Yeah. Now we'll add age to each values, and let's say we'll start with 21, 23, 22, 24. Okay, 24. and 20. Okay, 204 for some reason. Okay, now we have added age, and what can I take it in for examples? Let's, okay, yeah, just a basic example of each data science fundamental workshop, I guess. Score with 88, 45, 92, 77, 95, and let's ask what is happening here. Past. So true, 45 is going to be false, 92 is true, 77 is also true, and true. Okay, so we have our data set ready. I don't think there's any issue. Why is there a red mark here? No idea. What? Okay, there seems to be an issue here. I don't know why. Okay, I get it. So yeah, I missed a quote there. So now I've created a, data frame of sorts. And what is the issue here? So you can see it's saying that it's not closed because I haven't used equals to here, but it's still showing me the same error. But why? Because I've been using equals to in place of booleans. So my bad for that. I wanted to do it quickly and I messed up in between. Yeah. So this is it. Now, if I want to initialize this as a pandas data frame, right? So what I'll do is create a variable df and then pass bd is equal to data frame and then date. I wrote a date. Yeah, I'll you know pass this data set as an argument, and if I run this indentation error, so keep in mind about the indentations. And if I run this, it has been defined as df. And if I want to see my table right here, you can see if I just push past df, you can see a beautiful dictionary just became a formatted table. Now this is pandas data frame, the central object of all data analysis in python, right? Now if let's do a few more operations in this same data frame. Like if I want to add a new I want to calculate the mean of the scores here. So if I use this and run this, you can see the mean value of the scores. Like the scores are 88, 45, 92 and 77, 95. The mean value is 79.4 and it's a float value. Now I want to see only the past students, the students with passed, right? So if I write past equals true, and okay, wait a minute. Yeah, now if I run this, you can see it will only show me the names of the people who passed in the exam. Like the only one who didn't pass was Bob, right, with 45. So you can't actually see his value over here in this formatted table. Now one line will filter the table in single line, right? No loops, no manual indexing. So this is the power of pandas, and we'll go deep on it in module 2. Now in module 1 we meet numpy in depth, right? I guess that is it. Yeah. So what let's discuss what is going to come up next for you. In module 1, we'll meet NumPy and it will meet it in depth. I'm going to show you something that blows every beginner's mind. We'll time a Python list operation versus a NumPy operation on a million numbers. NumPy is typically 50 to 100 times faster for it. and I'll show you exactly why and how to use that speed. We'll cover n-dimensional arrays, indexing, and slicing in 2D, the concept of broadcasting, which is one of the most powerful ideas in all of numerical Python, and the random module for generating test data. Your homework before the next video is open today's Colab notebook, link in the description. Try changing the values and rerunning each cell. Break things, and that is how exactly you will learn. Every time you rerun a cell and see the output change, you're building intuition. Remember that. Now, all the resources from today's video are on screen now. Collab at collab.research.google.com, the Python docs at docs.python.org if you want to go through the Python documentation, Kaggle's free micro course, and of course, hackskill.in where you register for your certificate. Now, this is module 0 done. You have set up your environment, refreshed your Python fundamentals, run your first data science code, and got a sneak peek at Pythons. If this video helped you, please hit a like. If genuinely helps more learners find this, subscribe if you don't miss module if so you don't miss module 1, right? And drop a comment below telling me what you are most excited to learn. See you in the next one. Let's build something great together.